Welcome to MIT's Computer Science and Artificial Intelligence Lab's Alliances podcast. I'm Kara Miller. On today's show, MIT economist David Autor, who has helped us understand how past technological transitions affected jobs, gives us an inside look at the latest research on AI and employment. And while AI can effectively scale in some situations, like customer service, in others, it's going to have trouble.
We can have a Taylor Swift of popular entertainment who can, entertain 2 billion people. But we can't have a Taylor Swift of oncology or of medicine in general who can take care of 2 billion people. There's going to be a lot of people involved. And so even if we made the best doctor, 10,000 times better, that doctor would still have very finite capacity.
But what if AI makes your expertise less important and kind of elbows you aside? Autor says, it doesn't necessarily mean you'll be out of a job, but
generally when people are displaced from expert work, they don't move, they're going to tend to move downward. Or, you're doing the most well-paid thing, most expert thing you can do in all likelihood. That's your job. That's why you do that job.
That's all coming up in just a minute. If you want to know how AI is going to change the labor market, how it's going to change your job, your neighbor's job, and when exactly this is all going to happen, there's probably no one better to ask than David Autor.
I think a lot of people are sort of waiting. Everyone else believes it already changed everything, but it hasn't changed it for them.
Autor has served as a sort of national voice on the consequences of automation and outsourcing, and he's particularly proud of being cited by John Oliver a few years back on HBO's Last Week Tonight.
When automation does lead to job loss in certain sectors, historically, it's also actually created jobs, as this economist from MIT explains.
Let's do the following thought exercise. It's the year 1900, and 40% of all employment is in agriculture, right? And so some twerpy economist from MIT teleports back in time and says, 100 years from now, only 2% of people will be working in agriculture. What do you think the other 38% of people are going to do?
Well, I wouldn't know.
We say, search engine optimization, health and wellness, software and mobile devices. Most of what we do barely existed.
Exactly. That twerpy economist is right. 50 years...
So here's the deal when it comes to AI. Autor says AI does not have to revolutionize everything to radically change the economy.
Annually, productivity grows in the United States in a healthy, developed country, 1.5% to 2% a year. If we could raise that to 3% a year, that would be incredible. Like, over the course of decades, that comes to an enormous amount of economic growth. So it doesn't have to be revolutionary in every domain. If we could get one more point of economic growth annually, that would be, it would solve so many problems. It would solve problems of national debt. It would solve problems of the aging population. It would solve lots and lots of problems.
But which jobs will it upend most? Autor notes that if you survey people and ask them what job is most impervious to AI, they're pretty clear on the answer.
They will always answer in two parts. The first job they will say is nurse, and then the next job will be whatever it is they already do. And if many corporations are just sort of throwing it at their workers and say, here, use this for something, and they don't know what it's for. The only people who are making just vast, wild claims about what it's already accomplished are the people who are selling it.
Which is not to say that Autor thinks AI won't change our jobs, and we'll get to specifics in a couple of minutes. But zeroing in on the professions, the industries that will be most affected by disruptive technology, that may take a little time, as it always has.
Social scientists, and I would say engineers as well, are still in the same phase as everybody else in discovering, well, what is this good for? And what does it do?
Right.
And that process can take a very long time. It took a long time to figure out what electrification was for. It took a long time to figure out what we should do with lasers or GPS. And it took a while to figure out what were good uses of smartphones and the internet and so on. So if there was no progress in AI for the next 2 decades, except hopefully greater power efficiency, we would still have 2 decades of discovering to do, of saying, well, here's where we could use it well, or here's a great application, or here's where we should not use it, or here's a new idea of something we could do with it that we're not already doing.
So maybe it makes total sense that people feel like AI has been moving kind of slowly, at least in their own careers. Both employers and employees are trying to figure out how it can be most helpful. And then there's this. In lots of jobs, the stakes are high, and AI doesn't get things right 100% of the time. So whether you're in medicine or banking or manufacturing, the rush to AI, it's going to be tempered with some caution. Plus, and this is crucial to remember, every day we are running experiments on workers and seeing how they turn out.
We're very much in the sort of poking a stick at it and figuring out what happens phase of this technology. AI is not a better, cheaper, faster version of any other technology. It's actually not very good at many of the things that traditional computer software is good for. It's not actually good with facts and numbers, for example, which seems kind of ironic for cutting edge software. So it's hard to predict, and we should understand that we are still going to discover what it's useful for and what it's not useful for.
The key, Autor says, is not to think of this as an exercise in predicting the future, because that makes no sense.
We shouldn't treat the future as just a forecasting exercise, like it's somehow knowable if we could just look clearly. It's something that we are creating. It's a design exercise. And so what the future will look like and how work will change probably depends on what choices we make, right? We can use AI, for example, to build an incredibly powerful surveillance state that censors content in real time and monitors political speech and, figures out where we are in any moment. And that would be one future of work and, many other things. But that wouldn't be AI's choice. That would be our choice about what we want to use AI for. So there are a lot of things we can do with it, and we should recognize that we have agency. And so the future is not knowable in part because we don't know what we're going to do.
But, future aside, as I said, there is data coming in all the time on the jobs that will be changed and are being changed by AI. One stunning recent example comes from a large American company that works on material science. And to develop new materials for all sorts of real-life uses, they employ people with expertise in chemistry, physics, and engineering. Aidan Toner Rogers, a student of David Autor's, recently unveiled his work on this company. Here's Autor describing the research.
Material science is the part of, engineering that essentially brings you new glues and new ultra high strength, metals and things that can tolerate different temperatures and so on. And so it's really important to the way all products are engineered to be able to create these, specific properties. And they have over 1,000 PhDs, and they did a rollout of a generative AI product, not a large language model, that basically does what's called inverse materials discovery. You tell it the property of the material that you want, and it predicts a material design that would have those properties.
Okay, so you've got all these scientists. They are used to coming up with new materials without AI, and all of a sudden, they've got this new tool. What happens? Well, a lot.
It increased the discovery rate, the rate of new patent applications, and the rate of commercialization by 20 to 40%. So it was a big success, and the materials, according to their metrics, were closer to design specifications than previously and also more novel. So that's a big deal.
But the AI was not just successful in pumping more novel materials out of the R&D lab. The other part of the headline finding from this paper was just who the AI helped most.
For the scientists who were very productive initially, it was very helpful, and they became much more productive. And the reason is, interestingly, because the AI does a lot of proposing ideas, and it's the job of the scientist to dispose of the ones and just keep the good ones. And scientists who had good judgment and expertise were able to do that very effectively. But for many other scientists who didn't have that kind of instinct or judgment or maybe that training or practice, they were basically choosing at random from the ideas that the AI spit out, and it didn't make them better, and it made their jobs less pleasant as well. So there's a kind of complementarity between human judgment and expertise in this setting and machine judgment or machine expertise. And I think that looking for that complementarity is going to be quite critical in figuring out how to use AI well. And often when it goes wrong, it's because AI is producing, legal briefs or academic documents or writing where the person allegedly producing it doesn't have the expertise to evaluate what's good, what's reliable, and what's hallucination or what is, just bad reasoning or bad argument.
What's interesting is, you've done a lot of work on inequality. And what's interesting about this finding is that this is not a case of AI allowing me to create a website, even though I don't know how to code. Because that's okay. I don't have to have as much expertise because AI can just, use English and turn it into, like, do the coding. This is really a situation of the best people, like the smartest people, are even further away from the other people, right? This just amplifies expertise in the way that we've seen in other places too. I mean, did that surprise you?
Yes and no. So first of all, I agree with your take that it really was in this setting. It seems to like it benefit the superstars and not others. So why I say it doesn't surprise me. The part that doesn't is I feel like this is actually a kind of a consistent subtext of many studies on AI, that where is AI is useful to people, it's where they have the right judgment to work with it. And it can support judgment, but it can't replace it. So it can help you to do something that you're, don't have a lot of expertise in. But if you don't know how to evaluate the quality of the output, you're in trouble, right? If if you're not a lawyer and use it to write a legal brief, chances are it will have errors. If you use it to support your, mathematical explorations, it may be helpful to you, but it may get the wrong answer too. And so this is a setting where the right scientists were able to make the right judgments and others were not. And so I think we need to be looking for those use cases. So for example, it can allow professional copywriters to write copy more quickly. That doesn't mean a middle schooler could then do copywriting just using the same tool. And, or for example, in the case of customer support, we've seen that it helps people to become expert more rapidly because it essentially kind of models what a good reply looks like and so on. But I do think it's the right question to ask. Is this all going to be about superstars or is this going to be democratizing? And I think it's going to be some of both. I mean, there are certain domains, like you can imagine material science, they say, well, maybe we only need the top quarter of scientists. They're going to be so much more productive, right?
Exactly.
You could also imagine that they would say, well, actually, we're going to design a lot more materials. Or you could imagine they might say, hey, we can figure out how to get the rest of these scientists good at this as well. We just hadn't given any thought to how you train them.
Right.
But in some fields, this is not an option, right? So, we can have a Taylor Swift of popular entertainment who can, entertain 2 billion people. But we can't have a Taylor Swift of oncology or of medicine in general who can take care of 2 billion people. There's going to be a lot of people involved. And so even if we made the best doctor, 10,000 times better, that doctor would still have very finite capacity. And so we really want to make everyone better, even if we make some people much better.
Right.
So I think there are many settings where it's not going to be an option to just replace quantity with quality.
Do you worry, though? Like, I just wonder we've seen sort of a trend in the last few decades of the best computer programmers, the best scientists, the best people in finance really pulling away in a compensation type of way. And I wonder if of course, as you say, that it's not going to probably happen with kindergarten teachers, but if in certain professions that are substantial professions, if you worry, they can just get away with a lot fewer people and just really pay those people a lot of money.
Yeah, I mean, I do have this concern for sure. Now, it's important to recognize actually that the growth of inequality has actually slowed. And in fact, in the United States, earnings inequality, not overall inequality, but earnings inequality actually has come down substantially since the pandemic. And the kind of return to education, the college-high school gap, basically plateaued about 20 years ago. It's still very high, but it's not rising. I guess my concern is there's some of the superstar stuff, I think, as you mentioned, just makes the top person in finance and the top person in software and the top person in chip design and so on.
Yeah.
I worry more about people who are kind of, middle management or personnel or doing some kind of, the person who writes the letters of reference or the letters of reprimand or the improvement action plans and so on. So I do worry about displacement of kind of middle management. I also worry in terms of maybe in customer support. If I were a professional translator for a living, I would be very concerned. Not because I don't think there will be any more language translators, but most translation will be done by machines, and only the very expensive occasions, where the stakes are very high, will we, bring in expert consulting translators who will work with the AI as well. On the other hand, there's another case to be made that these tools will actually enable more people to do some of these high judgment, high stakes tasks to deliver more medical services or, kind of basic legal services, or to develop software, or to do design or do a better job in skilled repair and construction. You could imagine that it could sort of create more competition for the top and allow more entry in the middle. right? And that would be the good scenario. And that's something to hope for, not just to hope for, but to attempt to design for, right? So, for example, in medicine, I think that would be the best case scenario where you have people of different expertise levels all up and down the line. You have doctors, but you have nurse practitioners, you have nurses, you have technicians, and to allow the folks who are, not at the very top of the pyramid to have better tools and expand their scope of practice to do it more effectively, that would be good for them. It would be good for patients and would be good for the overall delivery of healthcare. And then, of course, if it does, in fact, if we are effective at raising productivity with AI, that creates a lot of potential benefits, right? That creates a tailwind that tends to raise living standards across the board. So I don't know if it's how disequalizing it's going to be. I mean, every technological wave is different, right? Sometimes people say this time will be different. They're always different.
Right.
I would be surprised if this one looks exactly like the last one, if it just continued trends. I can't say it won't happen, but that wouldn't be my prediction.
One final piece about this new research that I just caught my eye. So, you have this AI program. It's really helping at least the people at the top to be more productive, to find these new materials. But one fascinating thing is that most of the scientists appeared to like their job less after they adopted this AI program. 82% saw a decline in well-being. And it sounded like basically people were like, gee, I got into this line of work thinking that the job was X. And now you're saying I'm supposed to sit around and judge AI's creativity. Like, I'm not as happy about this. I just wonder what you make of that piece of it.
Yeah, this is a big, I think it's what people call the boring apocalypse, which is, we're just inundated with AI garbage. And, like I write a paragraph, I hand it to ChatGPT and say, turn this into a 150-page report. Then it does that. And then I email it to you, Kara, and say, here's my 150-page report. Then you feed that to ChatGPT and say, turn this into a paragraph. Right. And so, yeah, I think it's not a good world when in which the job of humans is basically to just keep an eye on the machinery and make sure it doesn't make a mistake. And it's very hard for people to do that well. It's hard for people to attend to that type of problem. Like, this is why, the Tesla self-driving cars are potentially dangerous. It's not because they don't have pretty good software, but it's just very hard for people to pay attention if the machine is doing much of the work. And so if you gave lawyers the job of reading machine-read legal briefs and looking for errors, I bet they would fail to catch many errors that they would never themselves have made. And so and that's what's happening with these material scientists. They previously spent about a third of their time on basically generating new ideas, and that fell to a sixth of their time. And they spent much more time evaluating AI's ideas and deciding whether or not they would work. And that's, I think that is a real worry. So we need to design systems in a way that retain engagement. And when that doesn't happen, can have really quite tragic consequences. There's at least one documented very terrible major airline crash that was caused essentially by the autopilot acting correctly, and correct in this situation meant to shut itself off because it couldn't determine the velocity of the aircraft. And the pilots at that point had essentially lost the instinct for high altitude, non-assisted flight. And so they couldn't do it. And the end result was tragic. And there was nothing wrong with either the pilots or the autopilot or the aircraft fundamentally, but the interaction between machines doing too much of the job and people losing the touch for it was really quite problematic. So we need a world in which people are engaged.
So let me actually ask you about another interesting piece of research. So we're kind of moving from this very high level, like people with PhDs doing science, to a job that's becoming, I think, only more common, which is working in a nursing home. And there's a recent paper that looks at robot adoption in Japan, a place that has A, embraced robots, and B, has an aging population, sort of this upside down pyramid, not that many young people, a lot of old people. In that, look, I was fascinated by this. In that look at how robotics goes over in nursing homes, it goes over pretty well. I mean, it really seemed to help things in the nursing homes.
Yeah, I think this is a positive example. And why is that? Well, working in a nursing home, there's a lot of good caretaking that goes on, but there's two very difficult parts of that work. One is it's actually physically demanding and dangerous, and robots can help with lifting people in and out of showers and out of beds and so on. And that's really important. That's how people get hurt in a care setting, is actually lifting patients. Another thing that machines are very good at, that people are not good at, is paying constant attention, right? So a machine that can monitor, about and let you know when something is going wrong is a very useful machine to have. You cannot have a person sitting by a patient's bedside 24/7, but you certainly can have monitors for heart and for oxygen and so on. And so this is, and medical settings are ones where people are overloaded with demands for their attention, care workers. And so having machines that can support, some of the difficult tasks and some of the attention-demanding tasks, and allow people to focus where expertise is needed or where empathy is needed, that's a very good setting. I'm extremely optimistic about the potential for using AI well in healthcare. I say the potential because I'm not as optimistic that we will use the potential as well as we could use the potential, but I think there's enormous potential there.
Well, and it seemed like in the nursing homes where robotics was used, people stayed longer. Like the actual workers stayed longer. They did not tend to get laid off. They were just there, but they were sort of moved to other things that apparently made them happier because they just didn't walk out the door, like they didn't quit as often.
Right. And it seems like it also improved patient care in that same setting. And I think we sometimes see this, and this is actually a surprise, right? So you and I we were just speaking about the boring apocalypse where AI, makes jobs sort of unbearable because they're so dull. But, there's another study, which I know you're familiar with, by our colleague Danielle Lee at MIT, my colleague Danielle Lee, and Eric Brynjolfsson at Stanford, and Lindsay Raymond, who was a PhD student here recently, and now at Microsoft Research. And they looked at AI being used for customer support of a kind of a high stakes setting with an enterprise software product. The AI didn't support the customers, it supported the workers supporting the customers by suggesting responses in chats. And one of the amazing things was, in addition to accelerating the rate at which workers converge towards expertise, it reduced the quit rate among workers substantially. And you might say, well, why is that? And this is a very high burnout job because there's just a ton of emotional labor. It's kind of like a road rage phenomenon, right? People can be rather hostile, right? They're in a hurry. They assume you're an idiot, and they want their problem fixed. And so the chatbot actually surprisingly does a fair amount of the emotional labor. It says, oh, I know exactly how you feel. I've been there, when of course it hasn't. And so, their sentiment analysis of the chats found that the level of hostility from customers to agents and from agents to customers actually both declined once this software was put in place. And so it actually kind of filtered out some of the tedium, but also some of the difficulty of dealing with other people, and made the job more tolerable.
I think one of the things that surprised me about the nursing home study was the how effective physical technology was. Like, this was not, word processing. This was not an LLM. That's not what this was. And I actually remember talking to Eric Brynjolfsson, who's now at Stanford, and Andrew McAfee, it must have been a dozen years ago. And they were just talking about, for example, how hard a job it is to be a waitress. Like, both as a sort of physical and cognitive job, you have to figure out, like, when are people done, when are they not done? You have to get between tables that are kind of too close together and that sort of thing. And I wonder the degree to which you feel like a lot of jobs in this country are physical jobs, whether you're talking HVAC, construction, plumbing, like a lot of physical jobs. Do you feel like technology is about to disrupt those jobs, or we are still a long way away from,
I think so. I think we're closer than we used to be, but we're still pretty far away. So these nursing, robotics in nursing homes, these were not basically, robotic nurses walking around saying, can I help you? Would you like me to lift you out of bed? Would you like a coffee? And, they are very specialized machines that could, that lift a person out of bed or help them with toileting, or help them with mobility or even communication. And certainly with monitoring, they're not really robots in the sense they don't move around. So, the physical world has always been more demanding for automation and computerization than has the cognitive world, because the physical world is so much more complicated than just symbolic reasoning. And, and so it's always been, this is what's called Moravic's paradox, that it's easier to have a computer that can play a genius game of chess and have one that can take out the garbage.
Right.
And the other thing about the physical world is there's really no room for confabulation or mistake, right? You can't approximately empty a dishwasher or, sort of care for a child or, maybe or maybe not burn dinner. And so you have to have very, very high levels of accuracy and confidence in a very uncertain environment. And so there's tremendous progress in robotics, and it's coming, and large language models have sped this up. Surprisingly, they are applicable not just to language, but to software, but also to translation, but also to sight, and also to physical motion. But it's still, I asked a roboticist not very long ago at one of these frontier companies, I said, well, how many years before I can just, get on the phone and call a robotic plumber who will come to my old house and take out the water heater and put in a new one? And he kind of turned white. He was like, that's not happening. Like, not in my lifetime. Now, maybe it'll happen in his lifetime. I don't want to say that. But I do think that requires not just, dexterity, but all kinds of reasoning and judgment. And so it's a not at all a specialized activity. And that's part of what makes humans so effective is we are so effective across many domains and so adaptable. And, we're not especially good at anything. But we're able to do many, many things. And then we develop tools to make us really good at the things that we can't do, kind of manually.
Yeah. Let me talk about an AI or just like general tech gap that you pointed out to me before this conversation. And I think one I have not heard talked much about, and that's the gender gap. Research pretty consistently seems to show that men use AI more than women. That's true at both older ages and like younger ages. If you look at like kids in school, so like in a class, if the teacher says there's no AI in this class, girls basically listen, boys don't. What are the consequences of that gap, do you think?
Yeah, it's too early to know, but this is a robust finding across a number of countries that women use AI more than women. It's also the case, by the way, that AI is used more and people are more positive about it in lower income countries than in rich English speaking countries.
So, interesting.
Yeah. But that is a great finding of this Norwegian study, that the part of the gender gap in usage is that when students are told not to use AI, women don't and men continue to. Is that problematic? In some sense, it is the case that I'm going to sound very old fashioned here, but, boys are drawn to toys, right? And so whenever there's a novel gadget, they will tend to use it, whether it's useful or not, right? So, in the era before computing, men were very into stereos, right? Who had the biggest audiophile system. And they always claimed it's because they just loved music, but then they stopped buying that stuff once they started buying computers. So it's not so obvious that was all about. But in the long run, it is going to be very important for people to be facile with this tool. And the more you use AI, the more you realize you just have to develop a kind of a knack for knowing when it can be helpful to you. And you have to have, and when it's not, and then how to make it helpful to you. And so I do think it is not a favorable development that AI is currently used more by men than women. And I think, when schools start to teach effectively using AI, they should make sure that they give assignments that require everyone to do it. I mean, I know many teachers are afraid of AI, but ultimately it's a tool we're all going to have to use. And it's not like a calculator where you just punch in the numbers and get the right answer. It's much harder than that to figure out how to be effective with it. And so we do want people to take advantage.
Well, and it also is the case that employers say they want people who use AI. So when top female candidates aren't using it that much, like that matters.
Yeah.
I mean, it's also interesting to me that it echoes a little bit like in the 1980s, about a third of people getting computer science degrees were women. That plummeted as computer science became a more lucrative profession. It plummeted to about 18-20%.
Right.
And I wonder if that there's a little bit of repeat of history going on there.
Well, in the earlier computer era, and then so everything you just said is absolutely correct, and I fully agree. But in the early 1980s, when office computing became very prevalent, actually women used computers more than men because they were doing, the word processing and, and a lot of the clerical, administrative, and information processing tasks in organizations. But we didn't necessarily think that was a positive development, although it's not clearly a negative one. But it is the case that women were at the frontier of computer scientists. They were some of the early famous computer scientists, and also some of the people who did a lot of the programming at Los Alamos, as the Hidden Figures movie will tell you.
Right, and Grace Hopper.
Yeah, exactly.
Yeah,
and even there used to be a job called computer. A computer was someone who did computations, and many of those computers were women. So I do. It's not a proud history the way this has turned out, and I hope AI will not be the same. Now, I mean, there are famous pioneers in AI who are women, like Fei-Fei Li of Stanford is just one of many, many examples. But then the early history of computing also had that.
So finally, I wonder if you can just when you think about AI, but you can also loop in robotics, as we've talked about it, what kind of worries you the most here, and what gives you the most hope as you sort of look out at the landscape of, the research that's coming in?
Sure. So let me say, I'm going to answer as a labor economist rather. I could tell you I'm worried about, biological weapons and so on and AI weaponization, but I don't, but that's not, my worries there are no more interesting than anyone else's.
Okay.
I would say, what's most worrisome is the potential for rapid displacement of human expertise, right? So expertise is the kind of know-how to do some valuable task, coding an app or baking a loaf of bread or diagnosing a patient or, replacing a hardwood floor. And sometimes the expertise can be go from being very scarce and therefore valuable to being too cheap to meter because all of a sudden machines can do it. Okay. Like this is what could happen with some of language translation. It's knowledge of how to navigate roads and streets used to be valuable, and now of course that's that information is available from your smartphone. And so I worry not about us running out of jobs. I don't. This is not a concern I have, but certainly people being displaced from expert work into non-expert work that doesn't require training or specialization. You say, well, what's wrong with non-expert work? And there's nothing wrong with non-expert work, but it doesn't pay well because so many people can do it. And generally when people are displaced from expert work, they don't move. They're going to tend to move downward. Or, you're doing the best, the most well-paid thing, most expert thing you can do in all likelihood. That's your job. That's why you do that job. And so when people are displaced from factory work, they end up in lower paid services. When people are displaced, who used to be working as, typesetters, they didn't mostly become software engineers, right? They became something else that probably was less lucrative. So this is my biggest worry, is the displacement and devaluation of expertise. I think that the greatest upside scenario is one where AI actually, extends the relevance and reach of expertise, allows people with the right tools to go further with the knowledge that they have and develop additional knowledge to do better. So, I like to talk about the example of nurse practitioners, not an AI example per se. Nurse practitioners are registered nurses who have an additional master's degree and additional practical training. And they can do things, they can diagnose, they can treat, and they can prescribe things that previously, had been relegated to the realm of MDs exclusively, people with 5 more years of education. And this is a social phenomenon and a very positive one led by women. It's not, women nurses who started fighting back in the 1960s for a broader scope of practice. But at this point, they are strongly augmented by a bunch of technologies, both electronic medical records, diagnostic tools, and even software that looks for, prescription drug interactions and so on. And you can imagine a future where they have better tools, they could have a broader scope of practice and, diagnose a larger set of diseases, recommend more treatments, to give more care. But you could imagine similarly more people being able to enter software development, more people being to do some legal services, to do kitchen design, to do skilled repair more effectively. And so the very good scenario is we would use AI to allow more people who are not at the frontier of education, right? So only 40% of U.S. workers have a 4-year college degree. That's a large number, but it's not even close to the majority.
Right.
To allow those workers to do more valuable expert work. And there's where I think AI can potentially be a tool that allows people to kind of level up or to do things that would be out of reach without these decision-making supports. So that's what I would hope to see more of. And let me be clear, we're going to see all kinds of things. So there will not be one, general case. There will be a heterogeneity of cases, some cases where it will just totally displace experts, some places where it will just make a few people superstars, and other places where it will allow more people to do good quality work in domains that need lots of people. And I hope we see a lot of that third case.
David Autor is professor of economics at MIT. Thank you so much. Such a fascinating discussion.
Thank you, Kara. It's always a pleasure to speak with you.
And we will have links to some of the studies that we just talked about in our show notes. In just a minute, a look at new research from CSAIL, research that could alter how and how easily we use AI. If you're looking for another great podcast, check out Me, Myself, and AI. In each episode, expert hosts and researchers talk with AI leaders from organizations like NASA, Upwork, GitHub, and Special Olympics to explore how they achieve success with generative AI and what challenges and ethical considerations they face along the way. Listen to Me, Myself, and AI wherever you stream podcasts. So imagine if AI could learn like a human, using context to decide what matters and what doesn't, just like we do. That's the promise of a new approach to training AI from MIT researchers who've developed a way for AI to learn that could make it both more powerful and less biased. To understand why this matters, let's look at how AI used to learn. Step 1, bring together huge amounts of training data. For a long time, that data had to be labeled by an actual person. So if you were trying to train a model to recognize pictures of cats, you'd have to show it a lot of pictures of cats and tell the model, these are cats.
There are so many of the initial machine learning data sets that were completely labeled by PhD students, labs, research labs across the world, completely human effort.
That's Sharut Gupta. She's a PhD student at CSAIL working on machine learning. Now, as you can imagine, labeling large data sets is incredibly tedious. So the labeled data sets were limited in size because, well, there's a limited supply of PhD students and almost unlimited amounts of data. But everything changed around 2017 when a new approach called self-supervised learning started to take hold.
So self-supervised learning tries to take a large amount of unlabeled data, but gather the supervision from the data itself. A simple example in the case of language is that if you have a sentence, what you can do is you can mask out certain words in that sentence and train a model which predicts those words.
Consider the sentence, a PhD student sits in the lab.
So in that case, if I mask out the word student, and if I give the model this whole other unmasked tokens, which is the PhD, sits in the lab, in that case, because of the words like PhD and other phrases in this text prompt, in this sentence, the model will have high likelihood of predicting the word student. So now your supervision comes from these other words in that particular sequence.
This breakthrough meant AI could now learn from virtually all the data on the internet, not just carefully labeled examples. It's a technique now being used everywhere, from large language models to computer vision systems to speech recognition. It's one of the key ways that modern AI systems learn. But Sharut and a group of fellow researchers are building on self-supervised learning to create even more flexible machine learning models that can be more or less sensitive to certain factors depending on the context. So take, for example, the role of gender in making predictions in a hospital.
First, we have to predict what medicine to give to a particular patient. And the second is that we have to predict the length of stay of a particular patient in a hospital. So a task which is predicting a personalized medicine depends a lot on the physiological characteristics of the person, the gender of the person, because medicine dosages and other things can vary a lot with the gender of the person. However, if you're predicting things like what's the bill or what's the length of stay of a person, you want such a prediction to actually not depend on what is the gender of the person. So what we did in this particular work is that instead of training multiple models for multiple different downstream tasks, can you train self-supervised learning representations in such a way that they can be easily adapted to each of these downstream tasks without requiring any further training?
So you can tell the model when to take gender into account and when not to take gender into account when making predictions without having to build a whole new model. It's a technique that her team calls contextual self-supervised learning. The implications go beyond just making AI more efficient. By teaching AI systems when to consider sensitive factors like gender, race, age, and when to ignore them, we might be able to build more ethical AI systems from the ground up.
This is exactly the point of this whole work. So to develop more and more generalistic and autonomous agents, the hope is that you can learn this general representation, which you can just adapt to different scenarios you need. So in some scenarios, you want to be sensitive to certain symmetries, in the others you don't. And just an adaptable model can do that very efficiently depending on what biases you want to prevent versus what kind of features you want to encode.
Right now, the researchers still need to encode the context for the models. They have to tell the model, take gender into account in this context, though not in this one. But
the hope is that we should be able to just learn what features should a model be sensitive or insensitive to just by looking at the data. If it can do that, then that'll be, I guess, the next frontier of taking this model to. And that's exactly what we are focusing on as a future step as well.
You know, I have to say, from like the perspective of a layperson, the tricky part about that seems to be that, like, if you just go back to the gender and hospital example, well, AI does not have an intrinsic set of values. You have to say, like, these are my values. My values are that we don't want to charge one gender differently than the other in terms of money. But I mean, AI doesn't know that. Like, maybe you do.
Yeah, that is true. We have to encode such, I guess, human biases in some way or the other, or like human preferences in some way or the other.
Yeah.
Which also is a thing which can be factored in through the data we kind of collect. For instance, if we are looking at medical data again, and we have like a patient report corresponding to the patient diagnosis, the way we write the report and the things we write in the report are actually already biased by the way our human preferences are.
Right.
So it is also in some sense factored into the data, but definitely there's a lot of work being done, which is how do you factor in these human preferences into these models?
this approach could change how businesses build AI systems. Instead of training different models for different tasks, which requires lots of data and computing power, companies could use one adaptable system that learns which factors matter in different situations. For fast-moving industries, that flexibility could be game-changing.
For instance, if you have a business in like fashion retail, fashion trends and human preferences change so abruptly, so suddenly, and change a lot over time. So in such dynamic environments with ever-changing responses, such a model which is adaptable and you don't have to like retrain your representation from large amount of data each time is the way to go.
Sharut Gupta is a third-year PhD student in electrical engineering and computer science at MIT. She was the lead author of a recent paper on contextual self-supervised learning. We will have a link to coverage of it in our show notes. And if you're interested more broadly in the question of bias in AI, check out our recent conversations around AI and healthcare with Marzieh Ghasemi and Karandeep Singh. And before we go here, if you, your company, or your organization wants to know more about this sort of research, MIT CSAIL Alliances connects business and industry with the advances coming out of CSAIL. Just reach out to CSAIL Alliances. I'm Kara Miller. This podcast was produced by Matt Purdy with help from Andrew Zukowski. Join us again next time and stay ahead of the curve.